Now we are going to design a push-down automata for the language L is equal to A power n plus 1 B power n such that n greater than or equal to 1. What can be the possible strings in this language? When B is taking a value of, n is taking a value of 1 number of B's, but preceding that there should be 2 number of A's. So there should be an extra A than the number of B's. So if there are 2 B's, there will be 3 A's. If there are 3 B's, then there will be 4 A's. This is how the pattern of strings in this language are. So for designing a push-down automata, we'll be using 2 data structures. One is an input tape. So let me place one string that belongs to this language in the input tape. The tape pointer is X, and we can use one more data structure, that is the stack. The pointer to this stack data structure is Y. So what logic I'm going to use is, as long as I have A, we are going to push it inside the stack. And for every B, we are going to pop 1 A. In that condition, for n number of B's, we'll be popping n number of A's. And after popping all the A's, when the X reaches this epsilon, traversed to the extreme right, then we'll be having one more A, only one extra A that will be available in the stack. If this is the case, then we can accept the string in the push-down automata. Using the push-down automata, now let me give the algorithm for that one. So what is the logic we are going to use? As long as my input tape is having a value, we are going to push that A value inside the stack and move the tape pointer. Now while your X is pointing to B and your Y is having on top A, so for every B, one A will be popped off. So we are going to pop that from A from stack and move the input tape pointer. Now after that, after all these things, after pushing all A's and popping 1 A for every B, we will be having epsilon. So if X is equal to epsilon, and Y will definitely have 1 A, should have 1 A. That extra 1 A should be there. So in that case, what we can do is, we can pop that A outside the stack, and from if X is equal to epsilon and Y is equal to Z naught, then we can accept. Now how to give the transition table for this particular push-down automata? We'll be looking at the state, input tape and stack symbol. So initially you are in state Q0, A will be in input tape, bottom of the stack will be having Z0. So in that case, we are going to push it. So Q0, A, Z0. And then when Q0, A, remaining A's, all A's, you are going to push inside the stack. Now then, after pushing all the A's inside the stack, B will be coming next. So when B is in the tape and A is in top of the stack, we are going to make a state transition for the first B, and we are going to move to pop that A also. Now after that, we will be in state Q1. For the rest of the B's, for every A inside the stack, 1 for 1 B, 1 A will be popped off in state Q1. So when we are in state Q1, when epsilon come, all B's are popped for 1 A. Definitely there should be 1 A inside the stack. So you pop that A also by making a state transition to Q2. So in Q2, only epsilon Z0 possibility should come. So if that is the case, you make a transition to Q3 state. Let Q3 be the accepting state. So it is by final state method. Let it be the accepting state. Q3 Z0. So how can we give the transition diagram for this one? So initially we are in state Q0. When a Z0 comes, we will be pushing any number of A is coming, we will be pushing that inside the stack. For the first B, top of the stack having A, we will pop and move to a state called Q1. In Q1, for all B's, 11A will be popped off from the stack. And from there, if an epsilon A comes, that A also will be popped off and will be moving to another state called Q2. Why are you making a transition from Q1 to Q2? Just to confirm that there is one extra A in the stack. That is also popped off. So after that, when epsilon Z0 comes in, you go to the final state Q3 and accept it. This is the corresponding transition diagram, and this is the corresponding transition table for this push down automata that accepts language a power n plus 1 b power n such that n greater than or equal to 1. Let me give an instantaneous description for the string a, b and z0. So initially for all a's, you will be in state q0. First A gets pushed inside the stack, so the tape contents and stack contents will be changed like this. Second also will be in Q0, B will be coming. Top of the stack will be having A, and this A gets pushed inside the stack. So the contents will be changed like this. Now only one B is coming. In that B, we'll make a state transition to Q1. For that B, one A will be popped off. Okay, so you will have the remaining stack contents as A Z0. Now if Q1 is having, input tape is having epsilon and top of the stack is having A, we need to make a confirmation that it is having only one A by making a state transition and popping off that A also. So now if you have epsilon and Z0 in Q2 state, that leads to the accepting state without any change in input and tape and stack contents. Now the string is accepted. So I think I made it clear in describing push down automata for the language L is equal to a power n plus 1 b power n such that n greater than or equal to 1. Thank you.